What do you see about the hyperbola shape? Remember, we have to get to know the standard forms and the shapes. So what do you see about the shape? I could do the 10-1, 10-2, 10-3 review, but we did that yesterday. So 10-4. What do you see? Yeah, good. So instead of ellipses where you have curves coming into each other, instead of parabolas that are just one curve, you have two curves going away from each other, either horizontally or vertically. True? Okay. Horizontally, what do you guys notice comes first in the standard form equation? Ooh, horizontally? X minus. Cool. Cool. Why is that cool? Check it. What's it look like? An X. Kind of, yeah? Kind of works, right? It's a messy X, but it's an X. It's an X. Okay, who comes first in the vertically one? It's a Y. Another extra piece. But that's okay, it's a Y, right? It's a Y. Anyway, so we have horizontally with the X first, we have vertically with the Y first, or if you understand, horizontal is the X variable, vertical is the Y variable. Horizontal, the X changes. First, the Y changes. Oh. Changes how? From the, okay, what's the first? Center of the ellipse is the guy in the middle that the ellipse doesn't touch, right? Center of an ellipse is the guy in the middle that the hyperbola doesn't touch. Did I say ellipse twice? I'm sorry. Center of the ellipse, the point in the middle, the ellipse doesn't touch. Center of the hyperbola, the point in the middle, whichever way you go, that the hyperbola doesn't touch. Okay, from the center, we go out to hit. What comes first as you go out along the horizontal or the vertical? The vertices, because there are two of them. How far away are the vertices? Well, just how far? What's the distance? That's all I'm looking for. Nope, not to the vertices. A, that's what I was looking for. The distance is A, and then we need to add it like Matthew's trying to do, either to the H, add, subtract, to the H for the horizontally, or to the K for the vertically. But A is how far, check it, isn't A who's underneath the Y guy, or A who's underneath the X guy? But careful, it's going to be the squared, just like ellipses, so we're going to have to square root. Yeah? And then who's B? Pause. Center, good. Vertices, good. What comes next? Since the curvature is away, where's the focus? Away. So therefore, if you're going away, what's the distance away to the focus? Still C, just like ellipses, except isn't this farther away from the center than the vertices? Instead of ellipses where it was what was the formula for C? Not that one. C squared equals A squared minus B squared. But hyperbolas, I need it to go farther. I need it to go away. So therefore, C squared is going to equal A squared plus B squared. Okay, so that's C. That's the vertex. That's the foci. The very, 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 very last thing is how wide for the branches to go. Is it going to be super narrow or super spread out or somewhere in between? It's determined by the asymptotes. The asymptotes. If these asymptotes were really, really squished, what's going to happen to my branches? Right? If these asymptotes were really, really stretched, what's going to happen to my branches? Right? Kind of. How inclined the asymptotes are determines the curvature. But remember, in slope and slope curves, there are infinitely many different slopes. The whole tangent line thing. Whew, means crazy. Come back. How do we determine the asymptote? What do you see over here off to the side? M. Who's M? Slope. Back from section 10.1. Tangent of theta. Yeah. I don't really have thetas now. M equals rise over run. What's the formula if you have 2 points for finding an M? Otherwise known as delta y over delta x. Yeah, y2 minus y1 over x2 minus x1. Difference in y's, difference in x's. Guys, for this, let's start with A, which can go up to the asymptote. Is the A a rise or a run? If this was ground, a balloon could rise. So is this rise or run? Do you run straight up in the air? Not us. Maybe the Flash or something, but not us. So we don't run straight up. We run over, right? So this is the run in the bottom. And B would be, there's the run. A. But this one, what's your A now? The rise. And what's your B going to be? The other guy. So then it's A over B, the rise over run. But here's an easy way of looking at it. Can't I just think maybe off to the side or down here thinking about M? Can't I just think of delta Y over delta X, which is going to be the, we can't call it a minor or major radius now. Because first of all, we're not even really caring about who's greater or smaller. We're caring about who's positive or negative. Let's do, can I do vertical coefficient over horizontal coefficient? And I don't like the word coefficient. It's technically a constant in the denominator. It's kind of gross, kind of nasty. But let me see if you guys can understand what I'm saying. Whenever we're doing M for asymptotes, plus or minus, the nice thing is asymptotes can always extend from the center, like the vertices, like the foci. The asymptote is going to go rise over run to get one way, and rise over backwards run to get the other way. We start from the center and we go up and over. Our asymptotes are going to be y minus k equals m times x minus h. We're going to use, I almost gave it away. What form of a line is this? That's ax plus by is c. What form? Nope, slope-intercept is y equals mx plus b. This. Point slope. There you go. There's a point hk and there's a slope m. Point slope form. What did I put in my point? The center. What do I take the y guy and take the x guy? In this one, who's the y? Who's the y? Do you see it? Eyes up, eyes up. Y guy. That's the slope to put here. Who's the y? For this one, b over a. Rise over run, change in y over change in x. For this guy, who's the y? A, and who's the x? Rise over run, this guy, plus or minus a over b. My h gets to be my hk, my center gets to be my point, and my m is going to come from the y guy over the x guy, or the y guy over the x guy. That's our yellow box. Let's go. Pause. In homework, guess what? I'm pretty sure that's not what I wanted. Let's go here, let's go here, let's go here, and let's go here. I'm pretty sure this is important too. Do you know how ellipses had that extra eccentricity part? How close to a circle are you? Hyperbolas can't have that. They're not circles, or even circular, or ish. Anyway. Hyperbolas don't have eccentricity, but hyperbolas have asymptotes. Which also has to do with how curved it is, but in a different way. Okay, red pen. There we go. And let's get to an example. What have we done for all of chapter 10, especially starting in 10.2? Because 10.1 had the m equals tangent theta formula and the angle between formula, and we kind of played with formulas and lines. But section 10.2, we had a yellow box, we had parabolas, we had standard forms. So what do you do whenever you're given an example of any kind of section with hints and clues and points? Draw a picture. Thanks, Tyler. Draw a picture. Guess I didn't need all that. Not all of you are visual, but enough of you are that it would be helpful. Matthew's starting to get the points, and he's saying, this is just his brain thinking out loud. He's saying X is changing, not Y. And some might, in the yellow box, see how that helps you attach to a certain standard form. So those of you guys that see like, oh yeah, X is changing, see if you can, from the yellow box, figure out which scenario we're in. This one. Pick a standard form like we've done all chapter. Write down that standard form and start saying, can I plug anything in? I feel like you should be over a little bit. Yeah. Oh, did I put it on? Thank you, thank you. It got budged and I forgot. Thanks, kid. Now is it good? Which standard form are you guys using? X minus? Ooh. Careful. Yeah, we have to get used to that. Minus is hyperbola. Why am I not just going to x squared and y squared? Why do I still have the minus in there? My center's not 0, 0, right? Do you see how this, well, first of all, do you see how it's this one and why we picked that standard form? Parabola would be eating the foci in a horizontal way. If you look at your pictures, the only way where there are vertices and foci along a horizontal line is that formula, that standard form. So then think about it and say, okay, well, if it's like this, where's the center? In the middle. Anybody figure out the middle between 0 and 4? That's a distance of 4, so what's halfway? 2. Pretend that my graph is perfect, which it's not exactly. Anyway, something like that. So what point is that? 2, 2. Yeah, and it's my center. So can't I throw in x minus 2 and y minus 2? Sweet. Hey, one of these letters is the distance from the vertex, right? A. So A is 2? Because from 2 to 4, from 2 to 0, isn't that a distance of 2? So that's my, oh hey, isn't that also my over quantity, not my up quantity, my over quantity? Sweet. 2 squared. Oh hey, and to the focus, that's a thing, right? That's equal to 3. Is that B? No. Isn't that C? So what did you do with ellipses whenever you had an A and a C but not a B, or a B and a C and not an A? Is B squared is A squared plus B squared. So I can plug in my 3 squared is 9, my A squared is 4. Can I get B squared is equal to 5? Why am I not square rooting? Because what can I just plug in the B squared spot? I could have gotten B equals square root of 5 and then plugged in square root squared, but either way, we end up with x minus 2 quantity squared all over 4, y minus 2 squared all over 5. P.S. Some people have allergies, so just because someone coughs or sneezes or blows their nose, no like shun shun, be nice. Just don't touch them. Anyway, so coming back. I forgot to say it's allergy season too. Those people aren't contagious. And Joe, I'm ignoring your comment because I didn't hear it. Okay, so. Not because I don't care. I just didn't hear it. Priscilla. Oh. Does it make sense? So once I found 2, 2, coming back to our yellow box, remember A is how far from the center to the vertex? And then C is how far from the center to the focus? And so what I did is I looked at my points and I said, okay, how far away is 2, 2 from 4, 2 or 0, 2? And I saw that change in 2 either way. And then I thought about 2 or negative 1, 2, and I saw that change of 3. Is that cool? Did they even make me sketch the hyperbola? Nope. They just said find the standard form, so I don't even need to worry about asymptotes. But this one says, oh, still just find the standard form. Okay, cool. They're not making me sketch it. I don't have to worry about how narrow or broad my branches are for the asymptotes until they ask for them. What do you guys think you should do? Yeah. Why don't you draw the points, attach it to a scenario, a standard form, and see what you can fill in. I'm going to do that too, but this time I'm going to freeze the screen so you can't see my work. Feel free. Feel free to collaborate. Joe, go ahead. Pass through means one of the branches passes through that point. Mm-hmm. One of the branches hits or passes through that point. Because I'm hiding it. It's frozen. I'm hiding. You guys are. We've done this before. You goofs. You're trying to fill in your own. I have to do it all at once, otherwise I get in trouble. If I stop, then I'm like, yeah. So I started to draw my graph, and I realized I didn't know how to do my tick marks. But the rest of it looks good. Uh-huh. I think I know what you're saying, and I think I agree. Okay. How do I know this? If these points came out from a middle, what's the middle between negative 2 and 2? Oh, and what's the distance? Which variable stands for the distance from the center A? A equals 2. Oh. So I know my center is 0, 1, which I already figured out, and then I also know that A is equal to 2, so can't I plug and chug some and say x minus 0 squared all over 4, right? 2 squared. Minus, careful, hyperbola, minus y minus 1 squared all over b squared. Did they tell me foci? I don't even know C. I do have a point, so that's a clue, right? So if that's a clue, how can I use said clue in order to be able to help me? The distance, I can do 1, 2. Where's it supposed to go? Good. Is that better? But the question still remains, how do we use 5? It is on the hyperbola. And you get, I already have vertices, don't I? I need B. Because vertex of -2, 1 goes that way. Vertex of 2, 1 goes this way. And it said that somebody had to pass through 5, 4. He can't. He's in direction, so he must have passed through 5, 4. But how does that help me? Can't do the asymptote because guess what? The asymptote doesn't hit the curve. The asymptote skims the curve. So 5, 4 can't be on the asymptote, sadly. Good ideas thinking about rise over run and triangles, but that's to the asymptote. And the asymptote's going to be somewhere else. Well, technically, it's more like that, but it's not going to be on the asymptote. But he is an X and a Y. What do I have down here? Booyah! What can I do with an X and a Y? Plug it in the X and the Y spot and be like, oh, 5 has to work. I mean, a lot more points work than 5, 4, but 5, 4 has to work. He's a point on the curve. True? I know. This one is a tricky one, which is why I made it an example. They didn't give me the foci. I couldn't find the C. They didn't tell me the B. They didn't tell me the asymptotes. So it's like, well, they gave me an X and Y. So there's an X spot and a Y spot. So good. And I end up with, let's see, 25 all over 4 minus 3 squared is 9. Come on. I can do math. I think Joe's telling us to get a common denominator. What do you guys think? We can get a common. Well, we don't have a B, and so we have to somehow find B to fill in our equation. Yeah. Eventually we'll come back to that form. Just right now we're trying to find the B for a bit. B for a bit. So we have options. Do you guys subtract? Get rid of the fractions? Or do you want to get common denominator? Subtract would be to take this guy to the other side. Get common denominators would be times b squared over b squared times 4 over 4 and mush them. Get rid of it would be let's multiply by both sides. Okay. We can do that. The most passionate response I heard, or at least the most persistent, was subtract. So subtract. Boop, boop. The rest to fight for what you want. So, wouldn't this be times 4 over 4? Life lesson. 4 minus 25 is negative 21, right? Does the subtracting make sense? A number and put it with the other number, and I made it a new number, right? Now you have options. I see some of you that are confused. I'm not sure why. It's algebra. We know. Can't we multiply by b squared and then divide? We could do that. Or we could cross multiply, which is something that is such a great technique. I don't know why we're usually. We could multiply the 4 and multiply the b squared and then figure out life from there. I don't trust that you guys know how to do that. So I'm going to go ahead and multiply the b squared. And then multiply the 4. And we're going to get negative 36 is equal to negative 21b squared, which cross multiplying will get you the same place. Be confident and do what you know how to do. Don't always follow the leader. Okay, so then b squared is equal to 36 over 21. What? I divided. Equal to. Isn't that deuce? 3 goes in, yeah? 12 over 7? I think. And I was about to square root, and Matthew's like, why not just plug it in? Why plug it in? Oh, because it's a squared. Oh, that's nice. So let's go ahead and take our form and say, okay, so x minus 0 squared is x squared all over 4. I knew him. The y minus 1 is what I didn't know. But now I know what b squared is, so I'm just going to go zoop, 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 plug them in. But do you think they are going to leave a fraction within a fraction? No. So we can make it 7 over 12, because dividing by a fraction is multiplying by its reciprocal. Boop, 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 done. Have you guys noticed, though, even though you still don't like them, you're not quite as terrified of fractions as you used to be? Understandable. Hyperbolas kind of have a lot going on, but do you realize you're not as terrified of fractions? I'm just taking the small victories as they come. Anyway. Boop. Oh, no! Come on, you knew it was coming. Standard form, just do it. I like it. Take stuff and then figure it out. Because the x stuff always came first, the y stuff always came second. So we always did that. But for hyperbola, the x sometimes come first and the y's sometimes come first. Okay. Look at your box. It's okay. Look at your box. What's true about the guy who's in front versus the guy who comes second? How do we know whether y comes first or x comes first? Positive. Who's positive? Y is positive. Yep. So guess who's going to come first? The y stuff. Mm-hmm. Mm-hmm. Okay, Joe's trying to give a warning. He's like, oh, something changed signs. You see it? I had to, because it's y stuff minus x stuff, because it's y squared, y minus k squared minus x minus h squared. I had to pull the negative out. That's how the form works. It's okay, make yourself a note in a colored pen. Be like, beware the negative, right? That's fine. Beware the negative. Don't just beware the negative, beware things are inside. Look at this coefficient guy. He can't stay. He can't stay. So pull him out. 64 divided by 16 is 4. Yeah, it actually makes it a lot nicer for filling in the blank. So the next beware was beware the coefficient. I need to factor. You guys know I'm completing the square by now, yeah? Hey, we're not as scared of that either anymore, maybe. How do you complete the square? 4. Cut them in half and square them, which is 4, but do you know how we got there? 4 divided by 2 is 2, 2 squared is 4. Negative 2 divided by 2 is negative 1, squared is 1. Yep. For the purpose of, right, trying to get us closer, or not closer, all the way to a perfect square. Are we tracking? So we're completing the square, taking the middle guy, cutting him in half. But why haven't I filled this blank over here yet? There, yeah, Salma's saying it. Joe is trying to explain it. There's that 4 and 16. So I'm putting 64, and I'm putting a negative 1. Because there's a negative on the outside of him, and there's a 16 times 4 over there. Don't both of your standard forms have equal to 1? Aren't we supposed to like divide somebody now to get nice little denominators and get the nice little standard form? Oh, we saw that trick. We can actually make this like a divided by 1/16 and that a divided over 1. this stinking little degenerate function.
Does that mean we put D in?
The hyperbola does not exist, but what does exist? Look at the, wait, 10.2, the very beginning. Didn't we talk about conics? There are 3 different degenerates. Let's figure out who he is. Why? Because they want us to sketch him, and just because he's not a hyperbola, well, we can't sketch the hyperbola, but we can sketch whatever it is. No, the degenerates. It's a point, it's a line, or it's 2 lines. Well, how do we know which one it is? We don't go towards the hyperbola anymore. We just go towards figuring out who he is, and we say, I don't know who he is. We stop going towards the y minus k squared over a squared minus x minus h over b squared equals 1. We stop going towards that because he's not going to go there. He's degenerate. So I added this to the other side, and I said, Then I'm going to plus or minus square root both sides because everybody has squareds. Everybody has squareds. Wouldn't this be plus or minus 4 times y plus 2 equals plus or minus? Now technically, we only need a plus or minus on one side. You could go through and do a positive divided by a positive, a negative divided by a negative, a positive divided by a negative, and a negative divided by a positive. You just end up with a plus minus. But all that to say, oh, that's weird. I think I got lines. I think I got 2 lines. Why?
Because it doesn't plus or minus.
Nobody's squared anymore. I have a y to a 1 and an x to a 1. Is that section 10.1, 10.2, or 10.3, or 10.4? 10.1. 10.1 had y equal mx plus b, ax plus by equals c. It had no squareds. This one has no squareds. He's a line. What kind of line? Well, I'm going to have to do some maybe division. I have to divide by 4 and divide by 4. Oh, look at this line. Now, you could keep going, or you could just say, hold on. I know point slope form. I can get my line right now. Do you guys see a point? I do. X minus x1. An h if it was one of those. We can call it h if you want, but x minus x1, I have a point of 1, negative 2, and I have a slope of plus or minus 1/4. So I'm going to go up 1 over 1, 2, 3, 4. Boop, 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 boop. Not dotted. Literally, this is the graph. And then I have up 1 and back 1, 2, 3, 4. And I pretend that hits. Oh, rise over run. So I went up 1 over 4, and then negative, I went up 1 back for the downhill and the uphill. Was it almost a hyperbola? So close. If this had been a 1, then we could have rearranged it, and we would have had a hyperbola centered here with asymptotes going out here in little branches. Sorry, here. Because the y comes first, so it would have been a but why wasn't it hyperbola? Guess what else would be bad for it to equal to? It's bad to equal to 0, and it's bad to equal to a negative number. But if it's a positive number, all we have to do is divide to the other side and make it a 1, and we're good to go. But a 0 or a negative doesn't happen. And if it's degenerate, basically, I would say get y alone and figure out who he is. But did I get y all the way alone? Nah, because I know point slope form. I got my point, I got my slope, and I cheated. But I didn't cheat. I shortcutted. But what if it was a hyperbola? Well, we had a little bit more work to do, right? If it was a hyperbola, wouldn't have we had to have found the HK, found the vertices, found asymptotes? We would have had to go to our yellow box and use all the clues to fill in. Does that make sense? But since it wasn't a hyperbola, to be honest, it was actually easier. It's like, 2 lines, we're done. So what's the one danger in tackling tonight's homework? Degenerates are dangerous, but to be honest, the degenerate just saved us time. What do you think I'm a little more afraid of?
Us burning out.
That's a perpetual fear. But no, I mean for this homework, section 10.4. Well, I was thinking in 10.4 we didn't get an example. Let me see if I can find one. Here you go. We didn't get an example of one that was not a degenerate. Does that make sense? Ours was a degenerate. Ours didn't equal 1, so then all we had to do was graph our lines. But if it did equal 1, now guys, hold on. We wouldn't want it to look like this, right? Do you see why they rearranged it? Because we want the positive one in front. Do you see why this is going to be one of these hyperbolas? Because the y is first. How would we, just as we're ending off class real quick, because we didn't get one that actually worked, how would you identify everything in this guy? Where's his center? Careful. You have to take the x guy, then the y guy. So it's going to be -1, 0, h, and then k. And then how would I get to my vertices? Am I adding to the x or to the y if my y comes first? If the y comes first? Adding to the y. So it's going to be -1. Wait a minute. How far to my vertices? 4 is there, but square root it, right? So I'm going to have 2. And I have to go the other direction also, right? How am I going to find my y? I'm adding to the y again, right? But I would have to find my c, right? A squared plus b squared. Now, could I plug in a squared? Could I plug in b squared? Could I find c, and then could I take my 0 and add c, and then take my 0 and subtract c? What's the last thing we're missing? Our asymptotes. How do we find, I know it's just getting worse and worse. How do we find our asymptotes? Y minus, why am I putting 0? Equals, plus or minus the y guy over the x guy. 2 over x. Oh, it's really that easy? Get out of here. Bye. My computer said stop, and I'm stopping. Happy nutrition.